All right. So we're going to try doing a little better job with these doors. I think if we can first find a way to connect them nicely to the roads, then we can also add randomness to their positioning pretty easily. Yeah, thanks for tuning in, Rollergraph. Have a good sleep. Yeah, quickly, so this is just, at the moment, just an experiment in random code generation. If you want to see a bigger RPG project, Greg Zegan, who was here in the chat earlier, has a Twitch channel. You can find him on Twitter and on Twitch and on YouTube. He is working on a framework for building RPGs in Elm. So I think like a random map generator would kind of be a cool thing that could potentially fit in with his project in the future. But it's also something that I've just been personally interested in general. And if you like procedural generation, there's this cool thing called ProcJam, which is a procedural generation coding jam. Let's see, I guess it's in about a month from now, sometime in November, where there's tons of people that are doing cool procedural generation projects. So that's something fun to check out if you're interested in this kind of stuff. And if you want to participate, maybe Elm is a good language for that. All right. So first, what I want to try to do here is write a test that's going to check and make sure that the position of the doors is always placed next to a road, or I guess alternatively saying that there's at least one road tile that's adjacent to each of the doors. So let's see, I think we'll have to maybe write a couple more helper functions to do that. So let's jump to our tests and see if we can kind of sketch out what a good API for writing this test might be. So I'm going to start with the same test template. And let's say that I'm going to move this one up to be next to the test about the in. And actually, why don't we do this? Why don't we put a describe here, in, and we can group these together. It has exactly one in. Then this is our new test, is connected to roads. So how do we want to do this? So we're going to get our map here. This is maybe a good thing that we could refactor. Actually, why don't we do this? So we've got this chunk of code all over the place. This essentially could just be called create map with the seed. Takes an int and gives a map.map back. Cool. So then we can kind of simplify our tests a bit, and wherever we have this, we can just say create map seed. Cool. So now we want to check that it's connected to roads. So how can we do this? So I think, well, I guess we could just write a helper that does that altogether. Basically, we want to find all the ins, and for each of them, that's interesting. For each of the ins, we want to make sure that the locations are adjacent to road. So we're ultimately going to have a list.all is adjacent to road. But we're going to kind of need some let expressions. Okay, so I think we're going to need to have an extra helper function that can actually capture and reuse the map and do some things on it. And I think we're going to need a let block here, ultimately. I guess we can write that in line. So we're going to have our map. And we're going to have, ultimately, we're going to have in locations. We're going to pipe that to a list.all, then have our is adjacent to, and expect that to be true. All ins adjacent to roads. Then we just need to calculate our in locations. Should be able to do that from map. And I think we'll need a new helper in the map. Why don't we call it find all in, and expect that this will give back a list of points. That sounds reasonable. All right, so we'll have to implement a couple things. So we'll have to implement the map.findAll. Let's go do that. I'm going to be exposing it. Find all. I'm going to take a tile that we're looking to find. It's going to take a map. And okay, we can rewrite these. So these both are the maps. So findAll is going to take a tile, it's going to take a map, and it's going to give back a list of points. And we should be able to write this in terms of fold. So I think we just want to fold, starting with an empty list, and we'll have a tile to find, and then in our accumulator function, we're going to, interesting, we have the tile, but we don't actually have the points. So we may need to change fold to actually give us access to the point when we're folding. Let's pause and do that. The fold, I think we can just change this function to add another parameter. So we'll pass the point and the tile. Same signature change is going to be here in our helper fold. Let's comment this out for a minute and fix this refactoring. Let's see. Up the syntax in somewhere. Oh, I didn't put a comma up here. There we go. Okay, and I can't find all. Okay, so let's write this. We're going to have the point, the tile, and the resulting list. So we're going to say if the tile is equal to the tile to find, then we are going to add the point to our results list. Otherwise, we're just going to return the current results list. Let's see, what's wrong with the syntax? Check the compiler. looking for a closing paren. Why are you looking for that? Oh, I didn't put an equal sign here. There we go. Alright, so what's wrong here? Oh, I forgot to pass the map to the fold. Alright. Now we have our compile errors here. So now this function that gets passed in, we need to pass the point, which is x comma y. Bam. Okay. So let's go back to running our tests. And I spelled expect.true wrong. It should be lowercase. Then is adjacent to. Haven't written yet. And this is not going to work as written because this is going to need a check, or this is going to need to have access to the map. Oh, and we actually have the map here. Okay, so we can pass map into this, then we can write is adjacent to. Let's write that. Is adjacent to is going to take a map, first of all, and it's going to take a tile that we're expecting to find. Then it's also going to take a point. It's going to return a Boolean. We've got the map, got the affected tile, got the point. Okay, so basically we want to check all the 4 points adjacent to this one and see if that point has the affected tile. Let's destructure this. We will return map, which is a function taking point. Let's do x minus 1, y first. Should return a tile. So that's the first part. I'm going to do this for each of the 4 points. Map.tile, map.point. Cool. It looks like this is having a problem because we fold. Take the point now in this function. All right. So let's try running our tests. Okay, we still have a problem on line 82. So it's expecting the right argument to be a function that takes a function from map to point, but it's actually a function that takes a list of map, point, gives a bool. Not completely sure which line it's talking about. Probably this one. And in locations, I think we didn't pass mapped find all. Okay, yeah, that was not a fun error message to understand, but yeah, what I was thinking through was trying to say, okay, well, it seems like something here is not the right thing. It doesn't seem clear what. So I'm going to look at in locations and verify that it's the right type first. And looking at this, I was realizing we never told it which map to find in, so this was probably the problem. Alright, now let's run our tests. Cool. So we have the failure that we wanted, and we also have a failing test case. It's speed 0. So let's show that. So here's seed 0. And indeed, the roads are not, the doors are not connected to roads. So let's fix that up. We go to the town. So if we have connect to roads and give it a point, then we can write a function that will add enough roads, connect this road to the point. And let's see. In the chat, someone was suggesting, yeah, maybe we could place the doors first and then add the roads from the doors. Yeah, that sounds good. I think it would make it also more complicated to have extra roads around. So I think I'm going to keep the random roads for now, and then just add a road that connects the door to an existing road whenever we have a road. Or, excuse me, whenever we add a door that's not connected. Okay. So let's write connect to roads. We'll take the XY and the dictionary that we're building up. And I guess we could just try adding. I guess what we want to do is find a location that we potentially want to add in and go in that direction until we reach another road. I guess we could maybe even try to make it do a random walk or something. That would get more complicated in terms of this generator though, because then we'd have to thread a seed through, because we wouldn't be able to know how many random numbers we needed until we actually finished connecting things. So let's try this. Let's just pick one direction, maybe straight up, and we'll just connect straight up until we either go off the map or hit another road. Let's try this. So let's have x point equals x comma y minus. And what we're going to do is check if the dictionary already has road at that point. Let's get x point from the dictionary. That equals just road. Then we're done. We'll return the current map, the current dictionary. And if not, then we're going to add that point to the dictionary. Let's see. Someone's suggesting we could use is adjacent to for this check. Yeah, I agree with that. I think we can kind of sketch this out, and then we could easily swap in is adjacent to for this Boolean expression. But I think this is a perfectly fine stand-in for the moment. I don't think it would structurally change our code if we use is adjacent to in place of this comparison. In any case, we'll still have to choose a next point of where we're going to place the road if it's not adjacent to anything yet. Let's see. So if it's not, if the next point is not a road already, then let's insert that into there, set the road at that next point. Okay, so that's a start. That actually passes those tests for the moment. switch back to our random map. Cool. So let's implement the same thing for the other doors, or the same test. I'm going to take a scribe around here, armor tops, copy the same test here for now. Update the text. All armor shops should be adjacent to roads. Alright, so this I think will fail. Yep, and that fails on seed 0. Let's take a look at seed 0 again. Here it is. Okay, so the armor shop is the second one. So let's connect it to roads. And yeah, there's a problem now because it's destroying the inn. And our test should catch that too. Yeah, so we have problems with seeds that don't, excuse me. We have problems with the test making sure there's always an inn. Okay, so actually, what we should do is find a point. Well, okay, for the moment, we just always use the point to the left as our next point. Oops, what happened? Oh, there we go. You always have to put a space after a minus sign. You're using it to negate a number. Okay, so that's a little better for that one. Let's add the same thing for our weapon shop. We'll copy this same test. See that fail? Yep, cool. Then in our town, and also connect this one to roads. Okay, so that's good. However, in this case, the roads to the doors don't actually connect to the rest of the road network. So actually, I think what would be a cool test to try to write would be to have, or I guess to check that each of the buildings is accessible via some route that takes roads and gets to the edge of the screen. That would be an interesting test, because you'd probably have to write a helper that could do some kind of graph traversal algorithm to find if each door could connect to the edge of the screen. That'd be a cool test to do. I don't think we'll have time to do that today, but I will plant that seed in your mind. And let's see, what do I want to do time today? I want to turn this back on to randomness. Oh yeah. So we have all of our tests passing right now. What I want to do finally, before we finish up for the day, is use random locations for the buildings. So we have this like 3, 4, 3, 4, blah, blah, blah. So let's take this and instead call it in location. And we'll do that here. We will extract another parameter and we'll pass, now we have to use .map4. Okay, there we've got the in running around. And let's do the same thing for the armor shop. So that's going to be armor location. And we're going to do the same thing for the weapon location. Then we're 2 more point parameters. This is to split this up now. Got to add 2 more of these. Now we're using random.map6. Ooh, it doesn't exist. Okay, so we're going to have to chain these randoms to get a random.map6. So let's see. What I believe we do is do this for our first 4 parameters. This is going to generate us a function that still needs 2 more points passed into it. So then we can take this, pass it to random.then, at which point, that's the right way to do this. Then we're going to add another generator and a function going to call that with it. So here's the next generator. Let's see. Through how this works. Actually, if we look at the source code for these maps, see the pattern of how to do this. .elm. Oh, I see. Yeah, why don't we just write our own random.map6? Actually, now that I think of it, there's probably a map6 in the random.extras package. Let's just write this own. So this will be map6. Take 6 things. We're going to have df give back the value. Then we're going to have generators, a, b, so on. F. Did I miss one? A, B, C, D, F. Gives back a of value. Oh, interesting. We can't actually destructure these. Okay. Elm random map 6. Yeah, here we go. Although map 6 is the maximum. So if we go beyond that, I guess we need to figure out how to do this with and thens. Alright, so we could use map 6 from the random extras package. But that is going to be problematic because as soon as you try to add more stuff, we're going to run into the same problem of not having a 7. Actually, here's another way we could do it, is we could package these up into tuples. So for instance, this first parameter, we could make these all be a tuple of multiple road locations. Try that. I'm going to turn this first three arguments to tuple, and destructure all of them at once. Then make these is random.map3 to create all of the road locations. And we're going to use this function to turn these three things into a three-valued tuple. Okay, interestingly that worked out. Kind of silly. There's also a way to chain these using and then, but it would take a little bit for me to work through the types, figure out how to wire that up. But this seems like a reasonable approach for the moment. And we could do the same thing here. We could package these up to a tuple as well for the building locations. All right. So we've got our maps. So now we have a lot of problems, probably because these buildings are getting placed on top of each other. So let's take a look at this seed. We'll turn off the randomness, hardcode that seed. Cool. So let's see what is happening. So it's the armor shop which is missing. So let's debug.log the armor location. And see what this is printing out. So it's at 5.3, 4, 5, 3. Okay, so it looks like it was under the road that the armor that the weapons shop wrote to. So for that, I think we can fix it by wrapping up or by swapping around this. So rather than making sure there's not a road there, let's only place a road if there is grass there. So let's swap this. So if there's grass, or actually, grass is our default. So if there's nothing in the dictionary yet at that point, then we will insert our road. Otherwise, we'll use our dictionary. Oh, bye, Arkham. Thanks for stopping by. And I guess let's also check the weapon locate. Ah, I see. So they're exactly on top of each other. Interesting. So I guess we need to move things so that they don't get dropped on top of each other. So why don't we do this? We can make a new thing called place near weapon location. Or why don't we call it place building? We'll put these three things into it. And what we'll do is we'll have it check, first of all, if there's already something on that spot, and if there is, it'll look for a different spot. let's call this place building XY and the tile and the dictionary. Okay, we're going to do an if statement. We'll say if the point at XY, nothing, then we're going to do that. Otherwise, we will try to place the building somewhere else. Let's try x plus 2, y plus 1. Why not? With the same tile and our same starting dictionary. All right. That actually didn't help anything. So, why not? Bug.log the dictionary. So what is at location 5, 3? There's an armor shop. Oh, I see. We didn't actually use our point. Still just using weapon location from the outer scope. So this needs to be x, y. This needs to be the tile that we asked about. There we go. Okay. That seems like a good fix for that. So if there's already something there, we're going to find a new point and try to put the building that other location instead. Let's use the same place building for the other buildings. Also a nice refactoring anyway. So that these 3 lines now are going to replace all the other building placement that we had. It does the move road, it does the insert, and it does the connect to roads. Cool. So now let's try our tests. Ooh, okay. We still have problems. Let's check this seed. Okay. So in this case, there is no weapon shop. So let's find out what happened to it. I'm going to guess that it probably went off the corner of the screen because we incremented. So let's find that. Sound.elm. So let's debug, print this out right before we try to add the weapons shop. Also, let's debug the weapon location. The 3.9 is where we're, oh, is that large enough for people to see? The 3.9 is where we're trying to place the weapon shop. There's already a road there, so then our algorithm is going to add 2 to the x, 1 to the y, so that'd be 5, 10. And I don't see anything at 5, 10, but actually I guess 10 is off the edge of the map. So, I guess we should check, and I guess we could use like mod pick. Have this wrap around. There we go. All right. So we'll wrap around when trying to find a new point. Cool. Let's try those tests. Oh, I forgot to take my debugging out. But it looks like we still have a failed test case. So let's check this one. Map. Main. Here's our new seed. So the weapon shop is not adjacent to a road because it's right next to the armor shop. Okay. How can we fix that? I guess we can fix it by checking not only that the tile we care about is empty, but let's also check that the tile to the left is also empty. Oof. Okay. Put these in parentheses. All right. There we go. Now all our tests pass. Cool. Let's switch back on the randomness. And there's our maps. Not that great, but we did go through tons of randomness, and there's probably actually good papers or information we could read somewhere about actual good algorithms to generate town maps. So I'm pretty happy with what we did today. We tried out using fuzz tests or property-based tests to get test coverage over randomly generated map algorithms. We could just define properties that we wanted to be true across all generated maps, and it would find seeds for which that failed. We also did a lot of randomness and worked through trying a lot of different things with the random generation and also with the testing approaches. So I think I'm going to leave it here for today. Thanks for tuning in, and I will see you all next time.